Hi, this is John Blyler, Chief Content Officer at Extension Media. Today I'm talking with Zach Shelby, who is the Director of IoT Technology at ARM. Zach, let's talk a little bit about the market for the Internet of Things and the role that standards play in that. Why do we need to worry about standards? What lies ahead?
Well, I think if you look at Internet of Things and the whole evolution from what we used to call M2M or automation buses in general in the 90s, is that it used to be about little silos of market. Companies early in innovating but making proprietary technologies, really trying to capture a little piece of a market. What that created, though, was really stagnant market growth. So the market for M2M has never been very large, even in cellular. What is different about IoT is that we're really talking about unifying the global market for this technology. And the driver for market growth is standards. Because to do that, you really need to break down the value chain in technology, right? You need software tools, software ecosystem, hardware, cloud services. They all have to be available for developers. And I think that's the big difference. Standards are needed for market growth in IoT and to break down silos.
So on the device, you're going to have certain things you need to worry about, standards, and then in the cloud, there'll be the other things as well. What do developers need to worry about there?
Well, I think one of the trends we are seeing is that we're trying to make software for embedded developers on microcontrollers a lot easier to access, get a hold of. And one of the big initiatives we have is called embed.org. This is an open software SDK and ecosystem community for embedded developers across ARM. And what we're doing there is making sure that all the communication tools, protocols, security, networking, Wi-Fi, Bluetooth to 6LoWPAN, they're all available online in the cloud for developers and for free.
Wearables is a part of the Internet of Things. However, 14 years ago, we didn't really call it by that name. There was a wearable technology drive. And I remember attending CTIA that year in Las Vegas, and they actually had a runway with models wearing what at the time were fashionable devices. Actually, today they look big, clunky things, right? A Transmeta processor. Development system of choice was called Nanix, which was a derivative of Linux. I have no idea what happened to Nanix. So maybe speak a little bit about how things are different now. There's some things similar. They were still concerned about low power and performance, but what's different, and maybe hopefully the tools are a little bit better now.
Yeah, so I think there's a few trends that have happened. Always when you're early in a technology, like wearables in the early 2000s, you have this huge variation in technology. Everybody wants to do the operating system for this, the operating system for that. It's really fragmented. Nanix is probably a good example of one of those guys that think, oh, we're going to be the operating system of this. What happens when technology matures is that you end up getting a software ecosystem that just becomes a common enough tool that everybody puts their energy into it. In this case, Linux. There's been lots of branches off in every direction. Things have all come back to Linux in mobile, in embedded systems especially. I think that's one parallel we can look at what's happening with IoT on microcontrollers today. It's been a very similar field, right? Hundreds of real-time OSs, all of them basically the same thing, a little bit different. We see those really congealing down to pretty big popular software ecosystems that are free, that are open source, and everybody can just access. So I think all the Nanix of today will go away in the end, and we can focus on building things that we connect to the internet. Now, if you look at hardware, those big boxes that you had in the past, that was a case of the feature size of a lot of the chip technology not being there yet. We didn't have strong integration in SoCs. Technology just to put those SoCs and even the financial benefits of that weren't there yet. So you ended up building these big, discrete, microprocessor with external memory and flash and everything in a device. We've come a long way since then. So for example, the 32-bit ARM Cortex-M architecture lets us go down to, and good example, there's a Freescale Kinetis chip today that is literally 2 millimeters by 2 millimeters that runs a full Cortex M0 Plus. And that is a 32-bit microcontroller that we can put internet-capable security, protocols, intelligence onto something that small. And it's very low power. So that lets you really build electronics that you can, today, if you look at wearables, they're starting to actually merge into clothing. Batteries are flexible, much more powerful. Screens are flexible. So you can actually end up getting into real wearable clothing. I think that's the big difference from today. And so probably the difference between things and sensors and clothing, they really start to blur. We don't make a big distinction.
Thank you, Zach.
Thanks, Sean.